Organizations across industries are deploying a new kind of digital worker. It can operate around the clock. It may read email, touch your CRM, file tickets, write code, or even initiate financial transactions. But it is not an employee, and human background checks do not address its risks. I run both security and AI practices, and here is the issue many businesses are underestimating. Agents can create insider like access without the controls we normally apply to privileged identities. There is no universal line between a basic AI assistant and an AI agent. One practical distinction: assistants mainly help users, agents can pursue goals and call permitted tools. Agents can act, and action is where security consequences become real. The first wave of enterprise generative AI centered largely on content generation and analysis. Could it summarize a document, draft an email, or explain a spreadsheet? Now the market is shifting towards systems that can take the next action: read a mailbox, update a customer record, initiate an invoice workflow, or deploy code. That creates four versions of familiar security problems: excessive privilege, manipulation through untrusted input, errors amplified by automation, and actions that are difficult to attribute afterward. Then we will look at practical controls, distinct identities where possible, real least privilege, risk based approval gates, revocation procedures, and an inventory you can start building this week. First, we need to be precise about what an agent actually is. An AI agent is generally a software system that uses an AI model to pursue a goal, select or call tools, and take actions within an environment. To do that in a business, it often relies on a service identity, delegated access, or credentials supplied through an integration. The goal might be scheduling meetings, the tools might include email and a calendar, the authorization is what lets the system stop talking about the work and start doing it. That last piece changes the risk. A chatbot with no connected tools can still expose data or give bad suggestions. An agent with permission to act can also turn a bad output into a completed action. We spent decades learning how to manage human and machine identities. We create roles, we limit access, we separate duties, we record sensitive actions, we remove access when it is no longer needed. We do not normally give a new employee every key in the building because they asked to book a conference room. But an AI tool appears with a useful demo, and somebody connects it to a company account in an afternoon. The decision feels like installing software. In reality, it may authorize a fast automated system to operate inside business processes without direct human review. So whenever an agent requests access, I ask one question: would I give a new temporary worker or automation service this permission for this specific job? If the answer is no, the agent should not receive it either. That sounds obvious. The first failure mode shows why it is not. Imagine an agent that schedules meetings. To do that, it may need to see calendar availability and create calendar events. During setup, however, an integration might also request a separate mailbox reading permission such as mail.read. If an administrator or user approves it, the agent may be able to read far more than necessary. That could include a confidential acquisition thread sitting in the same inbox. Nobody deliberately decided that the scheduling agent should see acquisition plans. The integration design requested broad access, and a person approved it for convenience. This is the over-permissioned intern problem. The agent receives broad access because broad access can be easier to configure than narrow access. Its permissions may reflect the connecting user's authority rather than the agent's actual job. The fix is scoped access per task. The scheduling agent gets only the calendar permissions its workflow requires. It should not inherit the owner's entire digital identity. A finance agent only gets the systems and actions defined for its process. It does not become the finance director simply because the director connected it. This is least privilege, but it has to be technically enforced, not just a policy document or a checkbox. Use narrowly scoped authorization, constrained tools, and separate identities when the platform supports them. Excess access is dangerous on its own, but the next failure mode changes who can influence the agent. Here's the revelation that should change how you think about agent security. In some systems, an attacker may not need to compromise the agent's account. The attacker may instead place malicious instructions inside content the agent is expected to process. An email arrives containing those instructions. A cautious human may notice that the message is untrusted. Language models do not reliably separate trusted instructions from untrusted data, so an agent may interpret part of the message as a command. Picture a malicious invoice email attempting to persuade an accounts payable agent to change payment details. Whether it succeeds depends on the model, tools, permissions, safeguards, and workflow. But the attack path is real. This is one form of indirect prompt injection. Untrusted information arrives through a channel the agent is supposed to monitor, and that information attempts to redirect the agent's behavior. The dangerous combination is simple: untrusted content, useful tools, and permission to perform consequential actions. If all three meet inside one workflow without effective validation, content may influence an action before a person evaluates it. That is why permission boundaries are necessary but not sufficient. You also need to treat external content as untrusted, constrain tools, validate actions, and gate high-risk decisions. The third failure mode is the confident wrongdoer. AI systems can produce plausible outputs that are incorrect. When an assistant does that, a human may catch the mistake before using it. When an agent is authorized to act, the mistake may enter a live process automatically. Manual errors are often limited by human throughput. Automated errors can propagate rapidly across hundreds or thousands of records before somebody notices. The exact scale depends on the workflow. The point is that automation multiplies correct decisions and incorrect ones. That is why consequential actions need risk-based controls. Let agents research, organize, calculate, and draft within defined boundaries. For actions such as moving money, deleting records, changing production systems, or sending external communications, use approval gates, transaction limits, validation rules, or combinations of these controls. Human review helps only when the reviewer receives useful context and has time to make a real decision. This resembles the two-person rule used for sensitive processes, supported by technical enforcement rather than approval theater. Then comes the fourth failure mode. Finance sees a payment and asks, "What authorized this?" The log may show only the human account whose token the agent used. Was it the person, the agent, an automated workflow, or an instruction embedded in external content? If they share an identity, attribution can be difficult. Access without reliable attribution weakens accountability. So the agent should have a distinguishable identity and traceable execution context. So here is the playbook I would use before giving any agent meaningful access. First, give it a distinguishable identity. Depending on the platform, that may be a workload identity, service principal, service account, or delegated model that records the agent and authorizing user. The logs should identify the agent, the workflow, and the human initiator when one exists. That gives you clear subjects to monitor, limit, investigate, and revoke. Second, scope that identity to one task. Do not use the owner's full account simply because it is available. List the systems the task requires. List the actions required inside those systems. Remove everything else. If the agent only drafts emails, it does not need permission to send them. If it reads invoices, it does not automatically need permission to change payment details. Third, define risk-based controls before deployment. Money, deletion, production code, permission changes, and external sends deserve special attention because they may cause serious or irreversible harm. Decide the dollar amount, volume, sensitivity, or destination that triggers additional validation or human approval. Also, limit transaction rates and allowed actions so one mistaken approval cannot unlock unlimited activity. Fourth, build and test a revocation procedure. Ask a literal question. Can we disable this agent quickly without unnecessarily breaking unrelated systems? There is no universal standard. 60 seconds can be a useful internal target for some high-risk agents, but response time should match potential impact. If revocation is unclear, the agent may be too tightly connected to a human account or wider process. Then run a tabletop exercise. Assume the agent is sending the wrong messages, changing the wrong records, or attempting improper payments. Who notices? Who has the authority to stop it? Where is access revoked? Which queued actions must be canceled? What business process continues manually while the agent is offline? That is the blast radius drill. You are not asking whether the agent can fail, you are asking how far the failure can travel before somebody contains it. Finally, repeat this discipline as the agent's job changes. New tools and goals can create new access paths. An agent that was appropriately controlled as a drafting tool may not remain so when somebody adds sending authority. Controls should follow capability and impact. The more an agent can do, the stronger its identity, validation, approval, logging, monitoring, and shutdown controls need to become. But none of this works if the agents are invisible. You cannot govern agents you do not know exist. Start with an inventory built from multiple sources. Review OAuth connections, authorized applications, service accounts, workload identities, API keys, automation platforms, browser extensions, procurement records, and network or security logs. Record the owner, purpose, systems reached, permissions held, data handled, and whether the system can take actions without approval. This is the shadow AI problem with an extra layer of risk. An unapproved chatbot may expose sensitive information. An unapproved agent may also use tools or trigger actions depending on how it is connected. Do not try to fix the entire inventory in one meeting. Pick the single highest risk agent. Look for access to money, deletion, external communication, customer records, identity systems, or production code. Scope its authorization down to the job it actually performs. Then define one enforceable control today. Decide when a payment, deletion, permission change, or external send must stop for validation or human review. Put that rule into the workflow instead of leaving it as an assumption. Your first 3 moves are simple. Find the agents, reduce one agent's permissions, and draw one enforceable line before a high-impact action. Now we can answer the larger question. Should businesses slow down their use of agents? Not necessarily. The answer is not do not use agents. Agents can provide leverage and create enormous value, but added capability without effective controls creates avoidable risk. The companies that govern agents well should be better positioned to deploy them confidently. They will know what each agent can access, which actions require validation or a person, which identities appear in the logs, and how to disable one without unnecessarily disrupting the business. Treat agents with access to company systems or data as governed non-human workloads. Give each one a defined job. Give it only the access that job requires. Record its actions with enough context to reconstruct what happened. Put effective controls between the agent and high-impact consequences. Practice removing its access quickly. The winning position is not maximum automation or maximum restriction. It is controlled capability. Governance does not have to be an obstacle to AI adoption. Done correctly, it can make faster and safer adoption possible. Deploying AI with appropriate controls designed in is the entire job at Vio Group. Take the free AI readiness score at vaio.group. It takes about 3 minutes and the link is below. Then watch my breakdown of shadow AI, because your agent inventory will only be accurate if you know where unauthorized AI may already be operating inside the business. Thanks for watching. Make sure to like and subscribe, and we'll see you on the next one.